So in today's video, we are going to be talking about the standard deviation and the variance. And in the world of statistics, there is actually a simple formula that relates the standard deviation of our data set with the variance. I'm going to write that out right here. So we have that the standard deviation, which is SD, is actually equals to the square root of the variance. So that simply implies that if we have our data set and we're supposed to get the standard deviation, so the first step is for us to get the variance, and then from the variance we can take the square root of the answer of the variance for us to get the value of the standard deviation. So we have our question right here that says that Michael is interested in knowing how much his friends spend on average in a day. He decides to ask each of them how much they spend and gets the following data set. So we have $12, $15 down to $15. So the question says we should find the standard deviation and the variance of this data set. So the first step is for us to find the variance of this data set, and after having the variance, we are going to be taking the square root of our answer to get the standard deviation. So whenever we have an ungrouped data and we need to get the variance, the formula for the variance is going to be, so we have the variance right here, summation, we have a modulus sign, we have a xi minus x bar modulus all squared divided by n. So this formula is almost like the formula for the mean absolute deviation. The only difference is that right now we have the square of the modulus of deviations. So the first step in getting our variance is for us to get the value of the mean, and we've actually done this when we're using the same data to get the value of the mean absolute deviation. And the formula for the mean is x bar is equals to summation x divided by n, and that's going to be equals to 12 plus 15 plus 17 plus 14 plus 10 plus 11 plus 13 plus 15 divided by, we have 8 of them, and when we do the math, we have this to be equals to 104 divided by, 107 rather. This is going to be 107 divided by 8, and we have our answer to be 13.38. So the mean of our data set is actually equals to 13.38. So the next step is for us to subtract the mean value, which is 13.8, from individual variables in our data set, and get the modulus and also square the modulus. So we are going to be saying that this is going to be 12 minus 13.38. Then we have the modulus sign. Please don't forget that whenever we have the modulus sign, it simply implies that any negative value is going to be positive, and any positive value retains its negative value. So we have the modulus of 12 minus 13.38, and then we square this, plus we have 15 minus 13.38, we square this, plus we have 17 minus 13.38, we also square this. So 12 minus 13.38 modulus, we have our answer to be, so this is 1.38 squared, plus so 15 minus 13.38, that is 1.62 squared, plus so this is going to be 3.62 squared. We have this to be 3.62 squared, plus 0.62 squared, plus this is 3.38 squared, plus 2.38 squared, plus 0.38 squared, plus 1.62 squared. So everything is going to be divided by the size of the data, and that is going to be 8. So I'm going to be using my calculator to work on everything we have in the numerator directly. And from my calculator, we have our answer to be 39.3932 divided by 8. So 39.3932 divided by 8, and that is going to give us 4.92, approximated to 2 decimal place. So the variance of our data set is actually going to be equals to 4.92. So that means our variance, we can say that our variance right here is actually equals to 4.92. So to get the standard deviation, we are going to be taking the square root of 4.92. So when I use my calculator, so the square root of 4.92, that gives us 2.22 approximated to 2 decimal place. So the variance of our data set is 4.92 and the standard deviation of our data set is 2.22. So let's go to the next question. And our question says that in a class, a midterm test was conducted and the result of the test is given below. So we're supposed to construct a frequency table for this data set and find the standard deviation and variance. So we've actually used this question to get the mean absolute deviation. So constructing the frequency table is not going to be a tough one. So the formula for the variance in this case of ours, so we have the variance formula right here, is going to be summation. So we have the f into bracket modulus, rather we have xi minus x bar all squared divided by summation f. So that simply implies that when we are trying to construct our frequency table, we are going to be making space for the square of the modulus of deviations rather. So let's quickly sketch our frequency table. So after sketching our frequency table, the next step is for us to get the value of the mean, and like we did earlier, the formula for the mean is x bar is equals to summation fx divided by summation f. So that means that we need a space for fx, so we can just put that here, fx. So let's quickly rush through the frequency distribution table for our data set. So the formula for the mean is summation fx divided by summation f. So fx is going to be the product of the individual frequencies with the corresponding variables. So that is going to be 10 times 3, that gives us 30, 11 times 4, that gives us 44, 12 times 1, that gives us 12, and we do the same all through. Let's get our mean. So we have to sum everything right here. When we sum everything from 30 down to 60, we have our answer to be equals to 429. So that means our summation fx is actually equals to 429, and the sum of the frequency, that is 3 plus 4 plus 1 down to 3, we have the answer to be equals to 29. So the mean value, which is 429 divided by 29, is going to give us 14.79. So the value of our mean is equals to 14.79. So let's get the modulus of the deviations, that is 10 minus 14.79, 11 minus 14.79, 12 minus 14.79, down to 20 minus 14.79. Please note that there is actually a modulus sign, so that means that any negative value you get is actually going to become a positive value. We've also done this when we're using the same data to work on the mean absolute deviation, so I will just rush through it. I'm going to be linking a video to that so that you can just check how we did it. So we have the first value to be equals to 10 minus 14.79, and that is going to be equals to minus 4.79. Because we have the modulus sign, it's going to be equals to 4.79. So the next step is for us to get the square of the modulus of deviations. So that is going to be 4.79 squared. So 4.79 squared, that actually gives us 22.9441. 3.79 squared, excuse me. So 3.79 squared is going to give us 14.3641. 2.79 squared. 2.79 squared is 7.7841, and we do the rest. So the next step is for us to multiply the frequency of individual variables with the square of the modulus of deviations. That's going to be equals to 3 times 22.9441. So 3 times 22.9441, we have our answer to be equals to 68.8323. We have 4 times 14.3641, and that is going to be equals to 57.4564, and we do the rest in such manner. So we have the product of the frequency with the modulus, with the square of the modulus of deviation. So the next step is for us to sum everything we have right here. So if we sum from 68.8323 down to 57.4564 all through 81.4323, we are going to be having, we are going to be having our answer to be. So let's just take this down. So that means our variance is actually going to be equals to 306.7589 divided by the sum of the frequencies actually equals to 29. So when we do the math, so 306.7589 divided by 29, and our answer is 10.58. So the variance of our dataset is actually equals to 10.58. So the standard deviation is going to be equals to the square root of 10.58, and using my calculator, the square root of 10.58 approximated to 2 decimal place is going to be 3.25. So the standard deviation of our data set is actually 3.25. So let's go to the last question. So our question says that the management of a gym is interested in knowing the age distribution of people that visits the gym. So for this, the management decides to look into the ages of people who registered for the next 6 months. Below is the frequency distribution of the age. So we're supposed to find the standard deviation and the variance for this distribution. So the formula for the variance is almost, if not the same thing like the one we used for the previous question, just that we are going to be replacing xi with xmi, which represents the middle class. So what I'm trying to say is that the variance formula, we can write that here, is actually equals to summation f into bracket the modulus sign, rather we have xmi minus x bar divided by summation f. So that simply implies that we still need the value of the mean for us to be able to calculate the value of the variance. So let's quickly sketch our frequency table. So the first step is for us to extract the details from our table down into the reconstructed table. So we have so we're supposed to get to the middle class, and the middle class is simply the average of the upper class limit and the lower class limit. So that means the middle class for 15 to 20 is going to be equals to 15 plus 20 divided by 2, and that's going to be equals to 35 divided by 2. And when we do the math with our calculator, so 35 divided by 2 is going to be giving us 17.5. So we do the same for the rest. So the fxm is actually the product of the frequency with the middle class. So that means 15 times 17.5, that gives us 262.5. This is going to be 282. So the formula for our mean x bar is going to be equals to summation f xm divided by summation f. So when we sum everything we have on the column of fxm, we have our answer to be 2049 divided by, when we sum everything we have in the column of the frequency, we have our answer to be equals to 67. So that means our mean is going to be equals to 30.58. So the next step is for us to get the modulus of the deviation, which is the middle class minus the mean. We've also done that earlier, so I'm going to just rush through it. So that means 17.5 minus 30.58, that is going to give us minus 13.08, but due to the modulus sign, we are going to be having a positive value, so that is 13.08, and we do the same for the rest. So the next step is for us to square the modulus of deviation. So we are going to be starting with 13.08 squared, and that is going to give us 171.0864. 7.08 squared, and that is going to be 50.1264. And we'll do the same for the rest. So the next step is to multiply the frequency with the square of the modulus of deviation. That's going to be equals to 15 times 171.0864, and we have our answer to be 2566.296. We have 12 times 50.1264, and that is going to be 601.5168. We also do that for the rest. So the next step is for us to sum everything we have right here. So we are going to be saying 2566.296 plus 601.5168 down to 1017.7184. So when we sum all of that, we have our answer to be 6402, that is 6402.628. so the sum of the product of the frequency with the modulus of deviation is actually equals to 6402.628. so that means that our variance is actually going to be equals to 6402.628 divided by summation f is actually equals to 67. So when we do the math, we have our answer to be equals to 95.56 approximated to 2 decimal places. So the variance of our data set is actually equals to 95.56. So the standard deviation is going to be equals to the square root of 95.56, and that is going to give us an answer of 9.78 approximately, approximated to 2 decimal places rather. So that simply implies that our variance is 95.56 and then our standard deviation is 9.78. So if you learned something new in this video or you actually enjoyed this video, I would really appreciate if you can subscribe to this YouTube channel, turn on your notifications, and also like the video. If you also have any question regarding this topic or any other topic, you can actually go to the comment section rather, and list those questions right there, and definitely I'm going to attend to them. Thanks for making it to the end of this video. We will see you in the next one. Bye for now.